Hi guys, and in this lesson we're going to be looking at the properties of a perfect square. Okay, when a quadratic expression is a perfect square. So let me start off with our quadratic, okay, because when we're completing the square, this refers to a quadratic expression. So we have agreed that the general form of a quadratic, it's when it's written in the form ax squared plus bx plus c. Okay, now this is the general form of a quadratic expression, and sometimes in the exam we may be asked, or maybe given the situation that you're in, you may be asked to complete the square. Okay, so before we go into completing the square, let's look at the properties, certain properties of when a quadratic is a perfect square. Now, if a quadratic is a perfect square, then the general thing to do is to say I'm going to take half to prove, and this is a neat little trick now I'm showing you. Okay, so let me make a note here. This is a neat little trick to know when a quadratic is a perfect square. To know that it's a perfect square, I would have to take a half. Okay, let me change my color. I would have to take a half of b. Okay, this b here, take a half of b, and what I'm going to do, I'm going to square it, and that must be equal to the product a here, a times c. Okay, so this value and this value must work out to be the same thing if the quadratic is a perfect square. Now in the last exercise, let's look at a quadratic expression that we had looked at in the last exercise to prove this. Okay, we had looked at the form, the perfect square, which is x plus 2 multiplying x plus 2. Okay, and we had decided that when this is simplified, and by now we should know how to simplify this because we have been looking at it. If you're still not sure, you could always check back our playlist on expanding binomials. Okay, good. But to simplify this, we're saying x times x, which will give us x squared, x times 2x, which will give us a positive 2x. Okay, and then 2 times x, we have another positive 2x, and 2 2's 4. Okay, so this will completely factorize. This implies that I would have a x squared, and I'm grouping my like terms here, so I 2x plus 2x will give us a 4x. Okay, and I have a positive 4 there. Okay, and that would be my answer. Now I'm interested in taking this quadratic here now, this quadratic that we have, expand and simplify this product here. Okay, and we're going to look at some characteristics that we have stated earlier. This little trick here, half of b all squared must be equal to the product AC. Now let's just split the screen a bit and let's check that. Okay, now if your teacher asks you put up a quadratic expression on the board and they ask you to figure it out or to tell them whether or not this is a perfect square, this you would have to use to determine quickly. Okay, so I would say I'm taking a half of b and then I'm going to square that. Okay, and that must be equal to a times c. Now what is a half of b? I'm really taking a half of b in this case would be 4. Okay, this 4 here, this 4 here. Okay, that's b if you make a comparison with the expression that we have up here. So I would have a b there, so I would have a half of 4, and then I'm going to square that. Okay, and that must be equal to, and what is a is the coefficient of x squared, which is 1, times c is the constant out here that we have, which is 4. Okay, so this would be c, this 4 here, this positive 4, so times 4. Cool. Now what I'm saying here is that a half of 4, I'm working out what's inside the bracket first, so a half of 4 is 2 all squared, and that must be equal to 1 times 4 is 4. Okay, now 4 squared is the same as 2 squared is the same as 2 times 2, so I'm saying 2 2's is equal to 4, and 4 is also equal to 4. So this implies that, hey, This is my answer, and my answer, because I have 4, is equal to 4. Same value on both sides of the equation. This simply means then this is a perfect square. Okay, let's try another one. Let's try another one quickly. Alright, now let's change this up a bit. Let me say 2, let's use 2x squared, okay, minus 8x plus 8. All right, and again, your teacher, tutor, or math coach may ask you to identify this quadratic expression and to tell them whether or not it's a perfect square. So again, to identify it, you would have to say, let me take a half of b and I'm going to square it. Okay, and that must be equal to the product AC. Now again, let's go through it quickly. I'm going to say I'm taking a half of what is b now? B would be negative 8. Okay, so I'm taking a half of negative 8 and I'm going to square all of that, and that must be equal to 2 is the coefficient of x squared, which is a. So 2 times, and in this case 8, this 8 out here is a constant. Okay, so I'm saying a half of negative 8 is really negative 4, and I'm going to square it. Okay, and that must be equal to 2 times 8, which is 16. Let me square that. I should have the square there, sorry about that. Now I'm going to say negative 4 times negative 4 will give me a positive 16, and 16 is equal to 16. So again, my friends, we have another perfect square. What is different from the first one is that in this case b was negative. Okay, we had a negative b rather, right, in this case. So again, that's a perfect square. Okay, now we have worked with quadratic expressions, and I've proven that they are perfect square when b is positive and b is also negative. So it doesn't matter the value that b carries, okay, whether b is negative or positive. Once a half of b all square works out to the same thing as AC, then we have a perfect square. Now we need to show you that that's not the case in all situations, because only b can carry a negative value. Now what we're going to be looking at now in the next property is that note, and let me make it clear here, note for a quadratic to be a perfect square, note for a quadratic to be a perfect square, a and c must always be positive. Okay, so if a and c, if a or c is negative, then the quadratic is not a perfect square. Okay, and we can prove that quickly. So let's just look at another quadratic very quickly, and we can prove that if a or c carries a negative value, then the quadratic is not a perfect square. Take for example negative 5 x squared plus 10x plus 5. Okay, so again, to prove that it's a perfect square, I would be taking a half of b, which is now 10. So I'm taking a half of 10 and I'm going to square that. Okay, and that must be equal to a times c. A here is negative 5 and c here is positive 5. Okay, half of 10 is 5 and I'm going to square that, and that must be equal to negative 5 times a positive 5 will give me a negative 25. Okay, and 5 is also 25. So 25 is not equal to negative 25. So in this case, we have proven that if a or c is negative, it is not a perfect square. Okay, all right, and that's it. And it's fun, and as we go along, you will see and you will get a lot more used to the whole concept of working with perfect squares, and later on we'll see how it applies to the quadratic function. Okay, bye for now. Good.